Hi, and welcome to day 2, where we're talking more about what it means to be similar and how we can figure out if triangles are similar. We can also apply these ideas to other shapes, not just triangles. We can look at rectangles, all kinds of polygons. But basically, here is a video that if you did want to watch another video, we're going to watch this video in class. So I think it's important that you do watch it. So maybe when you get done with this one, you can go type this in and take a look at it. Now, similar figures, and I say figures because I mean triangles, any kind of polygon or shape, are related by a similarity ratio or a scale factor. And if you remember what I had said on day 1, we have a little triangle, we have a big triangle. These are scaled in their size. So think about like a miniature version of something like a model airplane. Um, This one would obviously represent the model, and this would represent maybe the real airplane. So that's what's happening here. You have a factor that relates the relative size of the small object to the big object. If you look at the box below, it uses that word similarity ratio right here. It says the scale factor between two similar polygons is sometimes called the similarity ratio. And I'll just put a little arrow here because that's what they're talking about. The ratio of the lengths of the corresponding sides of two similar polygons is called the scale factor. The scale factor depends on the order of the comparison. So, what that means is if we're talking about the order being the big one to the small one, then we would use the big number first. If we wanted to know the scale factor, how the small one was related to the big one, we would use the small number first. So it's really just flipping the numbers. Let me show you an example what that looks like. Okay. So in this diagram, it says triangle ABC, and you see a little squiggly line and triangle XYZ. What this squiggly line means is that the triangles are similar. Okay, they're not congruent. Congruent looks like this, where you have the squiggly and the equal sign. So the squiggly really refers to the fact that they're the same shape, and the equal sign refers to the fact that they're the same size. But that's not what we're doing here. We're just doing same shape. So triangle ABC is similar to triangle XYZ. And here's ABC, and here's XYZ. And all we know is that AB and XY are similar partners. We can tell that from the similarity statement. Okay, well, that's not a problem. But when we want to know the scale factor, we always look at the sides. So if we want to know the scale factor of ABC to XYZ, well, that's going to be the same thing as saying the big triangle, because isn't ABC much bigger, to the small. And we want to take two corresponding measurements. So we would take the AB to the XY. But now the second part of this says the scale factor of triangle XYZ. Well, that's the small to ABC to the big. So we're going to take the small side to the big side. So we really have two scale factors here. They just depend on the order in which you're comparing them. Neither one is wrong. It just depends on what's being asked. So if you look at questions 1 through 4, they're asking you find the ratio of similarity, that's the similarity ratio or the scale factor, and reduce if possible. But notice they're not telling you you have to do a particular order of comparison. You could go small to big, or you could go big to small. And by big, I mean big polygon to small polygon. In number 2, you have triangles. So you could say small triangle to big triangle, or you could say big triangle to small triangle. Now it says here that we should reduce if possible. So here we have a 6 to 8. Well, how could we reduce that? Well, I think the way that we could reduce that is to look at it as if it were a fraction. And check it out in Desmos. If we type in 6 to 8, we get 0.75. Well, we typically don't use decimals as scale factors, but let's make it back into a fraction again. Does it simplify? Yes, it does. It simplifies to 3 to 4. So the way that we would write our scale factor is, sorry about that, 3 to 4, or 4 to 3. So you have to look at each one. Why didn't I simplify number 1? Because I knew number 1 was simplified. When we go and put 3 to 5, sorry about that, 3 to 5, I get 0.6. When I hit the fraction button, it's still 3/5. So see, I knew that 3/5 was simplified. So when you do number 3 and number 4, try checking to see if they are simplified and reduced. If not, go ahead and use Desmos to help you if you need that. Now on page 5, it says triangles are similar if their scale factor is the same for all pairs of sides. So now we have to take a look at not just triangles. If you look down here at number 2, we have squares, but we'll talk about that in a minute. Are the triangles similar? Well, we have to check out all 3 sides and see if the 3 scale factors are the same. So let's take a look at this. Here we have our small triangle right here. Here we have our big triangle, but I do not see a triangle similarity statement. And this is kind of a problem because I don't know which side, well, actually I do, and I'll show you a way in a minute. But at first glance, how do we know which side goes with which? They could have turned it on us and rotated it, and we wouldn't know. So what I'm going to do is I'm going to look at each one of my triangles, and I'm going to notice in the small triangle that I have a 6, and I have an 8, and I have a 10. Excuse me. So the 6 is the smallest number. So that's your small side. Your 8 is your middle number. So 8 is between 6 and 10. So that's your middle or your medium. And 10 is your large. That's your large side. And if we go over here to the big triangle, we have 12 and 16 and 20. 12 is our small side. 16 is our medium side. and 20 is our large side. So what we have to do is we have to set up 3 scale factors: a small, a medium, and a large. And we have to look at all of those scale factors and determine, are they the same? So for the small, what I'm going to do is I'm going to take the 6, and then I'm going to go over here and get the small one. I'm going to get the 12. So see what I did? I took the small side from the little triangle, and then I took the small side from the big triangle. That's where I got the 6 and the 12 from. Now I'm going to do the medium one. I'm going to go to the medium of the small triangle, and then the medium of the big triangle. And then I'm going to get the large of the small triangle, the large of the big triangle. And notice how I went left to right each time. I went 6 to 12, I went 8 to 16, and I went 10 to 20. I kept it consistent when I was forming my scale factors. So my scale factors are always small triangle divided by big triangle. Small triangle divided by big triangle. So now I have to figure out, are these the same scale factor? The easiest way to do that, if you cannot reduce them on your own, is to put them into the Desmos calculator. And you really don't even need to make them fractions again, because you can compare their decimals. And I'm just entering them all in. Notice how we're getting 0.5 for all of them, or 1/2. So the question I have for you is, can you tell that all of the scale factors, it keeps doing that, I'm very sorry, are 1/2? And that means all of the scale factors are the same. So we can say yes, the triangles are similar, and the scale factor is 1/2, or 1 to 2, or 1 to 2. So that's how the rest of this page works. Sorry about that. And what we'll be doing is working through these, trying different sides together to see if that works. And then there is practice on page 6 and on page 7, where we find missing sides, and we'll be talking to you about that separately. Thank you so much.